Yo, what's up? What's up? Welcome back. Today we're working on my image to text AI, I guess. So, project context. Gots need need some anti-aliasing on that 3D stream intro screen, dude. It looks so bad. Like look at that. Oh, jeez. Yeah, we're gonna have to loop back for that at some point for sure. Okay, so what are we doing today? We are working on image to text AI. So the idea is we might have like an image. We want to convert it into text so that we can like, I don't know. There's no real reason. I can't think of like any good reason. I just thought it would be fun, right? And we've implemented like the world's shittiest version of this, where we essentially like sample some area of the image and we just say like, we've found some characters that look like they kind of like increase in number of pixels filled in. And let's just like count how many bright, like how bright is the picture, and pick the brightest character that matches. And that works like okay, but it feels like you could get some like pretty good sub-pixel or sub-sample accuracy, I guess, right? Like if you were to have a sample that you're trying to match and it like looks like this, almost certainly you should put an X in that location, right? And so like, how do we find the best character in a way that's like not too expensive? The thought there is like neural networks, right? Because if we were to try to like, for each sample in an image, try every single letter and see which one's best by some metric of best, right? That should end up being quite expensive if you try every single character. Or you could try to like do some sort of like pre-computation, but then like there's way too many possible options. So the thought is we could train an AI, do the expensive stuff during training, and hopefully the neural network learns something about the like what it's doing in a way that like makes that information compressible and fast to run. So that's what we're trying. We've done this shitty version. We've also done some work to like make sure that we can turn that text back into an image. So you'll notice that like this is a picture of characters, which is going to be very useful when we actually start training. And then last stream we trained like baby's first AI, which was just like we took a sine wave and we were like, can we like learn this so that we made sure that we understood the like basics of neural network training. And so that's where we're at now. And so I think the first thing that we're going to do is we're just going to try to like define any neural network, try to see any training that makes sense, that maybe like even just to match our current state, right? Maybe we can just train a neural network to get to what we did manually. And then from there, we can start trying to do something more complex and smarter and better. Yeah. So let's start thinking about what does like a neural network for this guy look like. So what we've done so far, all we've done is we've said, well, we have these like nodes that are linear functions, right? So when we trained our sine wave yesterday, we were like, well, you could like approximate this sine wave with 3 lines, right? You have this line, this line, this line, and that's like almost a sine wave, but not quite. And so we kind of like built up this concept of you could approximate that with 3 linear functions that you add together, right? If you have like your graph, you have this linear function and then this linear function and this linear function, and you can just like add them up together, right? You can say, well, as long as I have a way to turn this one off at this point and turn this one off at this point and this point and this one off all over here, like then when you add them up, you'll get what you want. And so that's what like we have we defined like an input node. I guess like people in AI draw these as graphs because it kind of makes sense. So you have like your input, which is like input to sine, and then this gets like multiplied by 3 other nodes with like linear functions, essentially like multiply and add. And then these go through like activations that say like, okay, when am I going to disable this guy? And then these get like converged back into some output node. So that's kind of like all of the pieces that we have right now. Is just multiplications, adds, activations. And so we need to figure out how we're going to structure this problem of turning this image into text as this problem. And so I think the dumbest thing that we could possibly do is we have, say we like sample some area of the image. Like we have like for each character here, right? This is matching to like some area here. So if we like look at the sun, right? This @ sign is taking up like maybe like, actually we can check our sample size here. We have like 12 pixels by the aspect ratio. So I think it's like 12 by 20 or something is like this area. And so you could say like, well, 12, there's like width 12, 12, 20. So like, and each of those points is going to have like a brightness value for the pixel. So your input space is going to be 12 times 20 numbers, inputs. So instead of like this like one input like we were doing for a sine wave, we'll just take in this many inputs, which is like a fuck ton. So we might also want to like downsample that a little bit, but 12 by 20 is probably fine. What is that? Calc. 12 times 20. 240 inputs, which like in the grand scheme of things isn't a lot, right? Like these like image classifier networks, they're working at like 25 million parameters or something. So like 240 is like fucking nothing, and your computer can probably multiply 240 numbers pretty quickly. And the absolute stupidest thing we could do, I think, is just have 240 inputs and however many characters that we might want to place in the image as outputs, right? So we'll just do 240. These all get like, we'll draw like a simple case. Say we had like, instead of 240 inputs, we had like 3, right? Just say we were like sampling 3 pixels. And let's say that we had like 2 possible characters that we wanted to output, right? Like A and B. You could essentially say like, well, A is going to be some combination of like multiplying and adding all of these brightnesses together. So you might imagine that like, if this pixel is like the top left pixel, this pixel is the bottom right pixel, and this pixel is the center pixel or something. You could imagine that that might be enough information if you multiplied like, A might say, hey, I don't care about the stuff in the top left, so I'm going to multiply that by 0, and I care about the stuff in the middle like a little bit, so I'll multiply that by like 0.1, and I care about the stuff in the bottom like a lot, so I'll multiply that by like 0.9. And if we're just like only trying to look at brightness of the scene, that's enough to determine how much it thinks that we should draw an A here, where A looks like this. And then like you can do the same thing for B. And so if you like extend that, you could get like the shittiest neural network that we could make has just inputs and outputs and multiplies each pixel by some number, gets an output. So I think we'll start with that as our neural network, and then certainly we'll be able to do something better. Either better in terms of like computational efficiency or in terms of like accuracy, probably both. So I think let's start with that. The world's shittiest neural network. So we'll just do 240 inputs to like length of how many characters we are sampling as outputs. So we have like our little trainer over here. We have like one script right now renders glyphs to an image. One script right now trains a network. So I guess we'll start in like by adjusting the training network or the training script, and we'll pull in what we need as we go. Let me just make sure that we like committed everything at the end of the stream yesterday. So we did. Today's December 22nd. So I'm not going to lose anything if I just start hacking shit up. Okay, so our network is going to be one linear network, which just means linear is just like fully connected. So like if you have like 1, 2, 3 here, and you have like 2 here, linear means that we're going to make these 3, these 2, and we're going to connect everything to everything. 1, 2, 1, 2, like that. And we said that our input is going to be, I guess we'll take in, we don't really, how do I say this? The sample size right now depends on the font itself, right? Because we're loading in a font with a specific aspect ratio, this hack font. We're asking the renderer, hey, what is like your aspect ratio of this character? So we'll take in the aspect ratio here maybe, and maybe we'll just take in like the width and height manually. Or we don't even say to take in width and height, we just have to take in a number of inputs. And I guess we also should take in num outputs actually, because we don't know which characters we're going to map to. So we'll just say we're going to make one linear function num inputs to num outputs. Boom, easy. Our forward function, all he's going to do, where forward means like just run the network, run through that graph. he's just going to call this linear function and return that. So nothing interesting to see there. Return. And then when we construct our network, we're going to have to use some of this like font stuff. So I guess we can, for now, import image to text. I actually don't know. Python imports always confuse me. I don't really know if I can like just do an adjacent import automatically, that if I have to specify Python path, or if I have to do like .image to text. I can't ever fucking remember. So we'll just try this now and we'll see what we get. And so let's just return from main immediately, just so that we can see if our thing even fucking runs. Python 3, no such file or directory. So let's just quickly bring up my development environment. Just discovered this channel today. Your neural network stream yesterday was one of the best I've seen on the subject. Hey, thanks, man. Appreciate it. Glad to have you here. Okay, no module named image to text. So do I like, fuck. Exit, F foreground, quit, open up the shell again. What was I doing? I was going to try to import image text. So maybe I put a dot in front of it, or maybe we'll Google how to import adjacent files. Python import adjacent file. Because I always like struggle with this because I know that there's like packages and stuff, but I don't know if you always need like this init thing. Import functions, if they have functions next to training, if you have like underscore init in there. That makes sense, I guess. Okay, so that's my training script. And I just wanted to try if I put a little dot here. Does that work? Train. He doesn't like that either. Import image text from dot. Oi. It's so frustrating because like when you're using like C, you can just type, please copy paste my file in here. But I struggle with it so much with it. From project. Ugh. Can I say like without module? Relative imports in Python. That's kind of what I'm looking for. From ABC, from blah, blah, blah. Package, module 1, module 2. Yeah, okay. Maybe we do just have to drop that underscore in it there. Oh, wait. Let's try this. From image text import star. Attempted relative import with no parent package. So maybe I touch init.py so that it knows it's a package. Oh! God damn it. This is going to take me longer than like anything else related to the neural network today. Importing class within same directory or subdirectory. This is what I'm looking for. Python 3. Python 2. Make an empty file called init.py in the same directory as the files. Yep. Then just do from x import y. The same holds true if the files are in a subdirectory. Put an init.py in the subdirectory as well. Then use regular import statements. Okay. Python 3, same as previous, but prefix module name with a dot if not using a subdirectory. So, like, didn't I do that? Am I fucking high? I did image to text, ls. Oh, image. It's because image to. Fuck. No! It's because I misspelled text. Fuck, I had it the whole time. Do I need the init file still? I think no, right? Touch init.py python train.py. Wait. Didn't this... Maybe that doesn't work? Am I fucking high? The same holds true if they're... Do they need to be in a subdirectory? If init.py is not empty, then whatever is in init.py, blah, blah, blah. Why is it needed at all? Because it's how Python identifies directories that you're allowed to import from. Okay, all that makes sense. Dude, I swear I'm fucking losing it. Let's just like comment everything in this file other than this. Is it because... Does it need to be in a subdirectory? Like if I say like lib, and move image to text and init.py into lib, then can I do from, can I like then import lib image to text. Oh, god damn it. Oh, that works. Okay, fine. We'll just do it that way for now. That's fucking annoying. But it is what it is. Okay. Okay. So now we want to run our network. We want to load our like glyph renderer that we made the other day. So we'll say from lib image to text import glyph renderer. Glyph renderer is not accessed. That's fine. So now we'll make our glyph renderer like we did in our main over here. So we say renderer is equal to glyph renderer. Okay. Then we have our sample width and height. We did this by setting a sample width globally. So I guess we'll just do the same thing here. We'll say sample width is equal to 12. We might want to make this smaller if our network can't handle this, but we'll start with 12. And the height is the width times or divided by the aspect ratio. Okay. Okay, and let's use lowercase here because these aren't globals anymore. And then we should just be able to define our network with sample width times sample height as the number of inputs. And the number of outputs should be the length of our like character lookup, which I guess maybe it makes sense for that to be left in here. Sure. So we'll just import it. This will all like we're not thinking too hard about code quality and cleanliness or whatever right now. We're just trying to get something running. So I'm certain that this won't end up being a global array that we import later, global list as you're supposed to say it in Python. Okay, so hopefully that runs. If I like return here and I run our training script, we get something printed, which probably came from here. Yep. And we should be able to say that we should be able to look at our network parameters now. So we should be able to say like print net named parameters. And I think that this is like an iterator, so we should convert this into a dictionary like this. That's what we kind of learned yesterday. And we see a lot of weights in our input, and then a small amount of biases because we only have to bias the 5 outputs. So I think that's right. Can we like maybe say print net linear 1 shape? Or is it like I want to know like how can I like read how many inputs and outputs are on this guy? This guy has weight, which is a parameter, where parameter has like data. Yeah. So we can say weight, data, shape. And that is 228 inputs and 5 outputs, I guess, is what that is. Weights for 228 to 5. Which I think makes sense. 228 is probably the width times the height that we saw. Print sample width, sample height, and we'll say width height here. Okay. And I think that we should see something that makes sense there. 12 times 19. 228. Yeah, okay. Cool. Everything in there is making sense. So we have our network. 228 outputs, 5 outputs. And I guess what are we going to do when we train? So before we set up an optimizer, which we will still need to do, right? We're going to like have parameters. They're going to have hills. We're going to walk down the hills to get to the right answer. And the optimizer is going to choose how far we want to step. So the optimizer, probably still fine. We might have to adjust the learning rate because I don't know if the learning rate scales with how many parameters there are. That would kind of like intuitively make sense to me, right? If like, I don't really know what learning rate is. It's some multiplier to something. But you could imagine that if you're like, how much does this parameter affect the answer? If you want all of your parameters to change a lot, you might need to, like, if they're multiplied by the learning rate, each parameter will have like a smaller effect on the output if you have more parameters. So you might have to multiply it by more to make it move more. I don't know. I'm just like bullshitting. But it would be intuitive to me. So I'll keep an eye on this like learning rate, and we might have to adjust it. And before we were just using mean squared error as our loss. So we had like an input, sine x, output expected number. And we had to then just check what the difference between those two numbers were. What are we going to do? I actually haven't really thought about this all the way through. So if we're classifying between A and B, which one of these is like correct? You could like imagine this task, I guess, is kind of like an image classification. Kind of. Right? Like, you know, you have like image classifiers where you're like, is this image a cat or is this image a dog? And you get like two outputs, cat and dog, and they say like one of these is right. And you need to like make a probability distribution to say which one is the most right, do you think? That's essentially how those like classifiers work. So you can like kind of like normalize this like output space so that you could say like, well, I'm like, you know, 90% sure that this is an A and like 10% sure this is a B. And then what you do when you're like, well, which one do we think it is? We just pick the biggest number. So we could probably do that same thing here, where, but instead of it saying like, I think this is an A, it's just like a slightly different thought of, I think that this could best be represented by an A. But that's like a very, very, very similar problem. So I think considering this as a shitty image classifier initially is probably like the first thing that makes sense. Another option would be to... No, I think that is like you have to pick one. You just have to pick one. We don't have another option. Yeah, so this is classification. And so how do we like train an image classifier? We can look up like PyTorch image classifier, and I think there's like a little tutorial that they have on PyTorch's website itself. And so they define some network, convolutional neural network. I'm sure that we'll cover convolutional neural networks in this project at some point, but we'll ignore that. We'll ignore like what they're actually doing for now. What we're more interested in is how do they determine correctness, or how do they determine correctness? And so they like run their network. They get some outputs, and they have a criterion. Where the fuck is their criterion defined? Somewhere. Criterion. Criteria. Here, they use something called cross entropy loss. It is useful when training classification problem with C classes. If provided, the optimal argument weight should be a 1D tensor, assigning weight to each of the classes. This is useful when you have an unbalanced training set. Sure, I think we probably don't. Or if we do, we want it to learn that bias, so that's okay. Maybe, I don't know, we'll see. Input is expected to contain unnormalized logits for each class. Logit. What are these again? 1 over, or ln x over 1 minus x, which I guess probably just has a property where it's a continuous function that falls off towards negative infinity really aggressively and positive infinity really aggressively. So I would guess that like things that are very strongly in favor of thinking they're like right will go higher on this side, and things that think they're like really, really not that thing will be in here, and things that are not sure will be kind of somewhere in the middle, probably. Okay, so the input is to contain unnormalized logits for each class, and really we don't have to think about this too hard, I guess, because really whatever we feed it, the network will learn to produce whatever the expected input of this cross entropy loss is. Okay, so they use, where were we before? I came from here, training classifier. So they use cross entropy loss, and their inputs and labels are equal to the data that come from the train loader. Usually in an ML task, logits refer to the value of the last layer of a neural network. But like, I think it's like, I would imagine that it's more about the mathematical representation more than like where in the network it is, right? I would I would just guess that you could have logits somewhere else before. Like, I think that I've seen before, like, the last layer is often logits, especially in classification. But I don't know if that means that like I would be more convinced that there's a relationship of last layer to logits that's stronger than logits to last layer, if that makes sense. You know, like all lions are cats, but not all cats are lions, type of thing. Okay, so they use cross entropy loss. I don't really, I haven't finished reading this because I don't really know what this means. I know that they're using it to say one of them is right. There's probably some like mathematical reason why cross entropy loss is reasonable, and probably at some point we might want to read about other options for which type of loss to use and what other options there are. But for now, let's just say they did classification, they did cross entropy loss. We can do that too. Fuck it, blaze it, whatever. YOLO. God, how old did I just make myself seem by saying that? That's awful. Okay. So then they have labels, which presumably in like an image classification task would be like, I am either a cat or a dog. And so then I assume that the labels say either which index of label they are, or it's like a mask of which one they are. So let's maybe can we see like what shape this thing is supposed to have? I guess we can look at the cross entropy loss and see what its second argument is supposed to be. The input is expected to be unnormalized logits for each class, and what is the like right side of the expression supposed to be? Target. Like, what is the target? Is if containing class indices, shape this. If containing class probabilities, same shape as the input, with each value should be between 0 and 1. Okay, so our input's going to have a shape of like batch size to probabilities, hand wavy. So we're going to have like batch size and I think 5 in our case, because we have 5 possible classes, which means that the target needs to be n is batch size, so it's going to be shape n. And each item is going to be the index of the class that we want to be. Okay, cool. So in our case, like, say that we have like this character lookup list here. We have like index, this is going to be like 0, 1, 2, 3, 4, right? And so these are going to correspond with like which weight is an output from our neural network. And so like each one of these is going to have a probability, and we're going to try to like coerce the network into predicting high probabilities for only one of them. And so we are going to have to determine which one of these guys is right. Right? Because like in this example of theirs, they have data that's labeled already. Their data is just labeled as this is fucking cat, not dog, cat only. But we're going to have to like decide which one is best. So I guess probably initially what makes sense is we could just do the expensive thing of checking every single one of our options and determining which one is the best one and picking that one. Which seems reasonable. So let's think about that. Our glyph renderer, what this guy did is he basically takes a character, so we feed it like an @ sign, and he gives us back a bitmap of that character. And we like feed that bitmap into like the slot in our image where that bitmap belongs. So like when we did this, we kind of like iterate over the picture. And like here we go, like put the colon, then we like move over some amount of characters and like put the colon here. And if the shape of the bitmap does not match, which it won't, right? Because like shapes of like the characters have like different heights and stuff. Then we kind of like figured out where it would fit in the picture. And then put it in there accordingly. So I guess probably what makes sense here is if we're going to be doing like lots of comparisons against the source, like if we're going to calculate how good of a fit it is, we're going to look at every single glyph that we've rendered and subtract it from the correct answer and count the difference. What probably makes sense is for us to force every rendered item to be the same size, because then we don't have to do this like re-slicing every time. Yeah, so we can render every character, try them all against whatever slice we look at, and then pick the best one, use that as our label. That seems reasonable. So for each loop, we're going to have to do like get data. I guess we'll have to define a function, get data. And he is going to pick an image, pick a slice of that image of width by height. Then we're going to check fit of every single glyph against that slice. Pick the best one. Return slice plus best index. Which seems reasonable. That seems reasonable. So I guess we're going to have like a width and height. And I guess also, if we're going to be calling this like many times in a row, say we're going to say like, I want 100 samples, please. We're not going to want to return the same 100 samples every time. So there's going to have to be some sort of like class with state in it that like keeps track of what we've looked at and makes sure that we like randomize the data effectively, whatever. So I guess what makes sense is we'll get say class, what do we want to call this thing? Class, image sampler or something. I don't know, fuck it. And I guess when we initialize him, we're going to say the size of our samples is unconditionally going to be width by height. And I guess we're also probably going to want to take in our glyph renderer. That seems reasonable to me. We can say self width is equal to width, self height is equal to height, and maybe we want to actually call this like sample width height for, because you know we can spare a few characters to understand what the fuck is going on a little better. Then we'll store the glyph render as well. And at this point in time, we have no training data set, right? Which is fine, right? We only have this one image that we've been like playing with so far. This one. And usually you would say, I want like hundreds and hundreds is way too low. I want like thousands or millions of images. Because I want my thing to be like scalable across all types of images that we can run into. But in our case, where we're just like, let's train the shittiest neural network we can think of first, just to make sure that like our criteria for what is correct and what is not correct is like, okay. We can start by working with only one image. And if it works well on that one image, then we at least understand that like our network has the capacity to learn about the thing that we want it to learn, and that our like metrics for what is good and what is bad are good enough. And then once we have that, then it's easier to start saying, okay, now let's like start scaling up and trying to figure out how to make it more robust and like work in other scenarios. But for now, saying we only care if it works in this very one specific scenario will like simplify the problem for us initially, I think. So let's do that for now. So we'll just say that like we have our one image, and we will just manually grab him for now, and later we'll fix that. So I guess we have our single image, which we have passed in on the command line, and we convert our image by doing from PIL import image. We load the image from disk, image path. We convert it to black and white. And then we convert it into an array using NumPy. I don't know if you could go straight to torch here. That seems possible. But let's do this. Self image is equal to NumPy array. And maybe you can do like torch tensor right here as well. And maybe you don't need this NumPy array at all. Maybe we can just do this. Print self.image. And let's just kind of see what that looks like. So let's return before we do anything that will break us. Let's create our image sampler. Image sampler, who is sample width, sample height, glyph or renderer, and image path. Which means that here we need to say image path comes in, which means that we need to parse our arguments like we did over here. So I'm just going to copy paste the same argument parser because while they happen to be the same, they are not technically argument parsers for the same thing. So I'm fine with a copy paste there, right? Because the reason to deduplicate things is not because things, in my eyes, not because things happen to be the same lines of code, but because they serve the same purpose. And so I would argue that inputs to these two different scripts have two different purposes, even though they happen to be exactly the same. So let's do that. And then let's print out the sampler image and just see if that like turned into something reasonable. Let's see. So we forgot to pass image path. And so let's just pass one in. And main got an unexpected keyword argument image path because it's supposed to be I said image with without the A, without some vowels, image path. And this should be image path like this. Could not infer the D type of image. Okay, so when I converted this to a NumPy array before, I think it did infer the type of the image. So let's try NumPy array. Yeah, so that works. So maybe we do have to do like a double conversion from NumPy, from PIL to NumPy to torch. But we can eat that cost. That's no big deal. No big deal. Okay. So we have our image as a tensor, and let's just make sure that like the shape of this guy is also like what we expect. He should be like a 1080p image-ish. That's not 1080p. Is he supposed to be? Resized is large as fuck. What did I call? Which one of these is right? Maybe it's sample.ping is the right one? Yeah, it is. Resized is not the one I want. Sample. Okay, so this is a 1080p image. Seems reasonable. Seems reasonable. And we have that as a torch tensor with like values that look like approximately correct. Maybe dark down here, bright up here. I don't know. Fuck it. Like, we'll see. It'll become apparent quick if it's wrong. Maybe. Maybe it won't. Okay. So now we need get sample. It's gonna take itself, and he's gonna return data and label. So I guess we're gonna have to like search for an arbitrary slice of width and height. And I guess we're gonna actually want to say like get samples, and we're gonna take in how many samples that we want. So I guess, how are we gonna do that? Let's start by getting one sample and figure out what that looks like, and then convert that into code that will get many at once. Okay. So I guess you are looking for something of width and height. So you can take like a random index that, as long as it's less than the width of the image minus the width of our sample, and just pick one. That seems reasonable. So we'll say torch rand. Is there like rand n? What does torch rand n do? Size. Does this like return integers or floats? Size. So we'll say that the size is the image. I guess we'll just say rand image.shape first. And we'll see what we get out of that. We'll just print this and return nothing for now. And we'll come back to actually parsing the data. So we'll say sampler get samples 1 for now. And let's just see what that spits out. So he doesn't like... Oh, I forgot to return after. Which makes sense. So I got floats, which isn't what I want. I want integers. PIL to tensor and torch vision takes care of channel times height times width, etc. Oh, that's... Yeah, maybe I should pull that in. We'll see. I think for now I'm happy with just doing this, but I could see how... like if I'm loading lots of images, it might be faster. Like the double conversion is expensive and stuff. Yeah, we'll see. I think that you can also, if I remember correctly, in Torch Vision, just load the image directly, which probably cuts out some overhead of like PIL as well. But okay, I'll keep that in mind and come back to it at some point. But for now, I think this is fine. For now. So I want like rand int. So like torch rand int. Yeah, rand int low high. That's what I want. And can these be of like multiple dimensions? It does. So you can get like random integers in the range 0 to 10, but like for 2 by 2 dimensions. But what if I want like different ranges on the different dimensions? I guess maybe I just do those separately and put them together after. So we'll say I want rand int in the range shape 0 minus the sample height, which seems reasonable. Oh, I need like a low value. So the low value will be 0 and the high value will be that. And the size will be 1 for now, or n, I guess. So he just says the argument must be a tuple of ints, not an int. So we'll say n, comma, just so that he gets stuck in a tuple. Must be a tuple of ints, not int. Am I high? Rand int argument size, position 2, 0, 1, 2, unless it's... Oh. Hold on. Are my brackets right here? No. They're just clearly fucking wrong. Okay, so we got a tensor of 312 items, which is not at all what I wanted. I want a tensor of 1 item. Oh, no, I got a... Sorry. I printed the rand ints, not their shape. Okay, yeah. So, we'll say... y is equal to this random number. X is equal to the same thing, but with sample width. And then we can return, we can say data is equal to the image from y to y plus self-sample height and x plus self-sample width, which seems reasonable. And let's say, what the fuck is data? I misspelled width, so he doesn't like that. Where the fuck did I misspell width? Over here. Image path. Okay, yeah. So that looks like maybe like a appropriately sized sample. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 by something greater than 12. So that makes sense. Looks like we got like our sample. It's like looks like it's the wrong aspect ratio because each digit is 3 characters wide, but I think that's about right. And so now we just have to check each glyph against the data and see which one's best. So for character in, what is it called? Car lookup. We're going to say self glyph renderer, render glyph, or render, fuck. Image to text. We have a glyph renderer that has render car. Render car. And we'll render the car. Great. And we'll say let, or not let, item is equal to this. And then we just check the bitmap and we say bitmap minus data. And I guess we want to pick the maximum of the bitmap minus data. Absolute. Minimum. We want that to be the smallest number we can fucking find. So we actually kind of want like to like turn this into an iterator of some sort. Which I think you can do with like this for C in car lookup or something. Is this how you? Oh, it's too complicated. We'll just say best index is equal to 0. And here we actually want the best, we want index to come in here as an enumeration of this guy. Ooh, we're getting a little sketchy here. And we'll say best score is equal to 0. Or we'll say this would be like a really fucking big number. Float inf. Is that like a thing you do? Math inf? Yeah. And so we'll say here, we'll say if this, the sum of all of our subtractions, but absolute valued, is less than our best score, our best score is now that. So we'll say score, we have to factor this out into a variable. So we say how far are we from for each pixel. Remember that, add them all up, and if we are better, then this is our new best score, and our new best index is this index. And then we return data and best index. Seems kind of reasonable. Seems reasonable. Bitmap should be item.bitmap, and this subtraction isn't going to work. But we can maybe just run it and see how it fucking crashes. Would love to blast through computer graphics shaders as fast and logically as you go through this, but I keep getting stuck in small things that take forever to figure out. As an ML engineer, at first I was eager to comment here and obsessively correct everything, but I was selfish. Your learning process is great. Keep up the good work. You discovered mistakes and now how to come and also how to overcome them along the way. Thanks. Appreciate it. Yeah, just if you're trying to blast through stuff, I think you just have to keep making mistakes and break them down into like, make mistake, analyze, fix one by one, and eventually you'll get there. Speed just comes with experience, I think. Float inf. Is float inf different than math inf? Maybe. You're saying that I should do float inf. I guess we'll see what happens if I do math inf, because that's the thing I typed first. And if it's shit, it's shit. Oh, no import needed? Yeah, I could see that. But maybe a more expensive string parse. Maybe. I think ultimately it doesn't matter, but that's good to have in the back pocket for sure. I'll keep that in mind. Okay, so certainly this just won't run correctly. Certainly. So we can't subtract a tensor from a ND array. So I wonder if it makes sense for our glyph renderer now to start using tensors internally instead of NumPy arrays. Or we could let it continue using NumPy arrays so that it works in this script, and we could like build up a second cache here, which is like a little bit expensive in terms like you're like eating some memory cost for abstraction. Maybe that's okay. For now, I'm just gonna do that because I don't want to break. I want this script to keep working for now, so I'm just gonna say self. It is better. Fuck, I don't know. I guess for now, we'll just convert it into a tensor here when we're computing the score, and then we'll figure it out later. We will figure it out later. So, fix me. Expensive to NumPy to tensor all the fucking time. And we'll just fix that at some point. And so, now we get the bitmap. And we paste it into our... We're going to have to paste it into our thing. So we're going to make a new tensor, torch zeros. And what's his size going to be? He's going to have a height of whatever the glyph renderer says the row height is. Renderer row height. And his width is going to be... I guess we should just look for width here. So car width. And we're technically this is not correct, but it's good enough for now, where we're just going to try one character. We just try one character and say, yeah, that's how thick our things are. And for a monospace font, this seems to be approximately true enough. Although I'm sure that we'll find in the future that this is a bad way to approximate this. But for now, we live, we learn, whatever. Okay, so here we're going to have our row height by, oh my god, glyph, renderer, car width. Here we go. So we have zeros like this. And then we will just fill the top left of this thing, which is also almost certainly not right, by the way. Top left, it should probably like centered in some way, but whatever. So we'll say data is item tensor is equal to this. And we'll just say that the item tensor from 0 to 0 to the bitmap height and 0 to the bitmap width is equal to item bitmap. And I don't know if tensor torch is going to like auto convert that for me. Seems like it probably will. Right, this is like a numpy thing to a tensor, which I don't know. I think I can handle that, but we'll see. And then here we can do item tensor minus data. I think that's right. Is our input and output guaranteed to be the same size? Yes, because our sample height and width are no, they're not determined by the character shape. So how are we doing this before? Are these guys the same size? No. Oh, no, maybe they are. Hold on. Let's see. So we had this guy was saving, resized, and test. Ah. Okay. So we're sampling the image at some width and height in image space, rendering our characters, and our characters might be bigger or smaller than that sample size. So in order to do the comparison, we actually have to resize our sample to match the size of the bitmap that we got, which sucks. Fuck. Okay, so what I was doing here so here I have a tensor that is a constant size, and we put this guy in here, and then we have to resize our data to that constant size. Oh, which means that we have to do some sort of like linear interpolation or something. Fuck. Or we can make a big image up front. Let's do that. Self image big. Image image for comparison, we'll call it. And we can just say image for comparison is equal to this resize thing, where we find our output image size is like some ratio of like our character width and height to the expected width and height, which we calculated over here somewhere. Yeah, here we go. This is the calculation for width and height that we did yesterday, or 2 days ago, I should say. So we have the input image shape 0 divided by width times the renderer row height. Yeah, nice. And then we do the same thing for y. Oh, this is height. Sorry, this is height by width, not width by height. So this should be self.image shape 1 by width divided by width times self glyph renderer row height times self glyph renderer car aspect. or in our new world, self glyph renderer car width. There we go. And then we don't actually have to. Do we store this thing? Yeah, except we do torch zeros now because we're not doing numpy. And does it want zeros like? No, zeros seems reasonable. Its data type is torch event date. And now we take the image PIL, resize it to output image shape, which all of that looks reasonable. And then we just say self image for comparison is equal to, or there should be self image for comparison here, not output image. Nice. And then we just say this is equal. How do I like assign this shit without like overwriting it? I guess it's just torch tensor numpy array image for comparison, which means that we don't have to pre-allocate here. We just have to resize with these guys directly, I think. Yeah, that looks right. Yeah. Yeah, that looks right. Except it doesn't like... I'm getting like errors here, but... let's just see how it crashes. Because certainly it will crash. So it doesn't like that I misspelled car width for like the 40th time today. Unknown resampling filter. So I have to specify this, I guess. Image PIL resize. So this takes self size. Oh, it's because I have to put another set of brackets around this, like this. Okay, image sampler has no attribute glyph renderer. Did I mean glyph renderer? Certainly. Certainly. Glyph renderer. Glyph. Oh my god. Glyph B should be renamed to glyph. Jesus. I'm good at typoing. I've been doing a lot. Okay, so he doesn't like this item tensor torch zeros. Argument size must be a 2 elements, but found at type of float. Okay. So here, I guess we just have to say, cast this to an integer, and cast this to an integer. Okay. And he doesn't like that I can't... Oh, I can't assign a numpy and array to torch float tensor. So I wonder if I have to just manually say torch tensor here. Okay. Size of tensor must match size of tensor B. So item tensor minus data. Item tensor is 29. Data is 12. So we actually, when we're comparing, we don't want to compare to the data. We want to compare to the equivalent resized data in our big version. Fuck, that's fucked. Okay, so we... So here, data, we need like data for comparison is self.image for comparison. But with these indexes scaled. So we'll say y for comparison is equal to y times our like image comparison height over our image height. Yeah. Jesus. Oh, this is awful. Ugh. And, probably these need to be floatified so that the division results in a decimal number, and then all of this casts back to an int. And we do the same thing for x. So x for comparison is x here, and with shape 1, not 0. What is your Linux distro? I'm using NixOS, which I wouldn't recommend to anybody who wasn't already looking into it. But I like it. I'm running into a problem installing Node into my VS Code. I can run in the terminal, but it won't let me link us the files. Or I don't usually do backend. No help from me there. You put me in Node land, and I'm pretty lost, man. The tooling there is JavaScript developers going crazy. They've got a lot of stuff. Okay, so here I'm going for, instead of y to y plus sample height, I'm going to y to, for comparison, to the row height of a glyph. Yeah, because my output is the glyph. So using glyph coordinates here makes sense. So this goes to y for comparison plus the glyph renderer row height. And we do the same thing for x. But instead of the row height, we have car width. Okay. Okay. This is starting to come together. And then here we say the item tensor is this, and we subtract data for comparison. Okay. And if we run this, oh fuck. We run train, and he doesn't like this at all, because the slice indexes are floats, so we probably just have to int this guy. Int. Okay. Okay. Certainly I've got some, like, fucking rounding errors in here. Certainly, but, what does he mean, bracket not closed? What the fuck is he bitching about? This one's closed, this one's closed. What is he complaining about? He doesn't know shit. Oh. It's because I put it on the wrong side of the colon. He does know shit, turns out. Turns out that the Python interpreter interprets Python pretty well. Who could have seen it coming? Okay. So I would like to maybe see... It would be nice to visualize this. So we could look at the data for comparison, as well as the best character it picked. I just want to know what each of those are. So let's say data image dot from array numpy array, or is it torch to numpy? I think it's data dot numpy. Yeah. Dot save, and we'll save this as data pung, and then we'll say for comparison gets saved to data for comparison. And then we print the best character. Best. So we look at car, look up best IDX. And maybe we also print the IDX just in case it's 0. And maybe we print the score as well. So here, best IDX, best score. Okay, that should probably be enough to, like, give us a clue. So his best score was 99,274. That's a really big number. Like, a really fucking big number. Okay, so we have data is here, which is this tiny subslice. Data for comparison is what looks like it could be the same subslice. That looks like maybe the same. And the best character was 0, which means empty. And so the question is, do we think empty is a good answer there? Let's run it again and see if we pick a different section. Do I have to press reload here? Okay, so this one's quite bright. So here we got index 4, which is an @ symbol, which I think is pretty reasonable. So it looks like the upscaling is, like, working somewhat correctly. And it also looks like the selection of which one is best is also hand wavy working somewhat correctly. Yeah, okay, that seems reasonable. I'm also realizing now that we don't actually have to do this comparison like this. We don't have to do it that way right now. Because essentially what we're... Oh no, that's bad. That's fine. That's better than what we were doing before. I was gonna say we could just sum up the pixels to get what we were getting before. But this might learn us something better. So let's try this first. Okay. So we have now got one sample. And now we want to get many samples. So let's kind of say that we at some point started working on our data loader. data loader. And we have now successfully load one sample. And now we know that we are at 1 hour and 5 minutes into stream. Means that all of these guys are going to end up with longer numbers. And we are now at load more than one sample. Okay. And let's line all these guys up just so that it's pretty in my brain. All right. All right. So, I guess also committing here is a good idea. We'll just say temp. Oh, whoa. Get rm cached lib pycache. Fuck that noise. And I have to do r, I guess. Okay, there we go. Git commit -m checkpoint loaded one sample. And we will clean that up later. So now we want to load many samples. So I think all we have to do, I actually don't. I was hoping that by the end of that sentence I would know the answer, but I don't. So presumably these x's will now need to. These are going to be like many x's and many y's, which means that these are going to be many x's and many y's. So if I punch in 2 here, if I punch in 2 here, let's just start like seeing what breaks. Certainly something will break. So train. What keyboard do you use? You type mega fast. I will argue that the keyboard actually does not impact that at all. That's just I played like instead of like doing university properly, I just played Type Racer in the lecture halls with my friends. And so we just got really good at typing quick. It was also really fucking annoying to everyone else in the classroom, I'm sure, because I'm sure it was just really fucking loud when we're just like typing as fast as we fucking can during a lecture. But that's how we got here. Yeah, keyboard's irrelevant. It's just about practice. It's always about practice. I'm wondering if it's taking the brunt. Oh, I see. I have a Durgod K20. I don't really know where it came from or why I bought this. Or K320? Yeah, there we go. Yeah, it looks kind of like this. It's this one. I don't know why I bought this one in particular, but I did. Okay. So if I try to run train, so he doesn't like this now because the Y for comparison is trying to be he's doing like multiplications of a tensor of a bunch of random numbers to a single float and then trying to cast that back to an int. So we actually want to do, probably instead of just this like int cast, there's probably some way to do like, Torch, could you please convert a lot of numbers at once for me? I think it's like torch 2. And I guess first we'll do this thing without converting it to an int. And then we'll say y for comparison to torch int. And I'm pretty sure, if I remember correctly, that's the way to do conversions in Torchland. But we'll find out in a second if I'm wrong. And so I would like to see print x for comparison, y for comparison. I would just like to see if those are reasonable. So here I see x has 2 indices. Wait, is that right? Yeah, so I see 2 x indexes with larger numbers for the upsampled image for comparison, so that looks good. And the y one also looks about right. So these look reasonable. And then it's bitching because I am trying to index the image by this tensor, and it doesn't like that. Only integer tensors of a single element can be converted to an index. I thought that you could pull out data for like, if you have like a list of indexes, I thought that if you pass that to a torch tensor, it gave you the data for each of those indexes. I thought. Okay, so let's get here and let's just see what, like if I do self.image y, is that valid? Yeah, it does. It's okay with that, but I can't do the range like this. Hold on. Let's just return here. And I think that you can do, like, if I do y plus sample height, no x's. We'll ignore x's for now. It actually doesn't like that, which is interesting. I guess if you're doing lists of indexes, we would need to build. Oh, that's gonna fucking suck. So we could say like y indices is gonna be a list of indexes from y to y plus self sample height. So if I print y indices, we should now see like a incrementing. Fuck. hold on. This also needs to be converted to integers. Let's see. No, it doesn't like that either because I can't. Oh, because I'd have to like arrange for each one. Oh, this is like a pain in the ass. Are you new using PyTorch? Not like brand new. I worked with it a fair amount before at like a previous job. It's just like I've never been really good at like manipulating the tensors in the way I want. And I actually never clarified this. So the reason that like it's better, like the reason I'm like trying to do this with like torch operations, is because like looping over indexes in Python is like slow as fuck. And so it's like always better if you can like manipulate the numbers in Torchland and get what you want out of them. So that's why I'm trying to do it this way. But I always fucking struggle here. So it's always good to ignore x's. Good one. Okay. So here we have. These are each. Okay. So y is a list of numbers in the range idx. And so we're trying to get this to be yn to sample height idx. That's what we're trying to get, I think. No. We're trying to get this to yn sample height, where each element in the sample height is going to be idx plus n. Or fuck, I'm using n again. We're trying to get from 1 to sorry, we'll use different indexes. So if we have like y index like 100 and 200, we're trying to get this to 100, 101, 102, and 200, 201, 202. And then I think that we can index our image with those. I think. Maybe? Is that the most efficient way to do this? Who fucking knows? Because we're trying to get like, right, like, cause like, I'm gonna punch in like 4,000 here. And I'm gonna trying to pull in like 4,000 of these guys at once. So getting this right is like reasonably important. Torch arrange. So this guy has a start and an end. How did you learn PyTorch? Just by like, I worked with a AI project before with someone with much more experience than, well, with many people with much more experience than me. So I just kind of like read code and tried to understand and tried to fill in what made sense where I needed to make changes. Yeah. Okay, can I make like, I guess you could make, I've got an idea. So I could make one thing of 0, 1, 2 to sample height, right? Which would give me like indexes that I could probably use here. Typically you learn by reading the docs. Not here, not in this brain, I don't. Docs are for nerds is what I always say. But you're right, I should learn by reading docs. I often skip that step. Okay, so we have 0, 1, 2 to sample height. And I would like to try converting that into like two sets of, like, if I add 100 to this, I would get the first thing that I want. And if I add 200 to this, I get the second thing I want. So I could generate one arrangement. Indices is equal to torch arrange 0 to self sample height. And this will give me indexes in the range 0 to sample height. Then I can basically duplicate this for how many ends I have. Yeah. So torch repeat. Is there like torch repeat? So basically like do the same set a bunch of times. Repeat interleave. Repeat behaves differently than numpy repeat. Is more similar to numpy tile. Repeats the tensor along the specified dimensions. Yeah. So I can repeat this n times. Yes. Is equal to indices is equal to torch. Repeat indices n. Okay, now let's print the indices and see, double check that I understand what they are. Torch has no attribute repeat. Okay, so why? Oh, torch.tensor repeat, not torch repeat. So this is indices repeat n. Not genuinely curious cellular, not being passive aggressive here. Oh no, I would. I didn't think you were. Yeah, for me, I just find it much easier to poke and prod stuff. Like you generally will be like, I think that this is how this is gonna work. I make a guess and then I test it, and if the world is consistent with my guess, either my guess is correct or my guess is good enough for my current mental model. And as long as I keep updating the mental model when I see things that are inconsistent with my understanding, hopefully then like eventually we get to a point where the guess becomes closer and closer with reality. And often that process involves reading the docs to some extent. But I often find that like docs are like hard to write correctly. And so I find it, I worry about like relying on them too heavily. Is basically the, and I'm bad at reading, just really bad at it. I can't focus long enough to read like 2 paragraphs. It's a disaster. Okay, let's print out our indices here. And so now we have 0 through 18 twice in a row. That's perfect. Mwah. That's what I want. Because now I can, maybe I can repeat this along a second dimension. So I think you do like n1 or something. Is that what I saw it say? Like you specify, oh, it's dim equals 1 maybe? Dim, what did it say here in the doc? It said, along each dimension. Oh, so maybe the size here of the repeat. Yeah. N1 seems like it would probably do maybe what I want. Yeah, here we go. Look at that. 2 sets of 0 to 18. Which is what I want. And so now I can add each set with the index. Yeah. So if I do indices plus y. It doesn't like that. Fuck. Tensor of size 19 must match the tensor of tensor B2 at non-singleton dimension 1. Okay, what are the shapes of these guys again? Print indices shape and y shape. So here I have indices shape is 2 by 19, and my y shape is 2. So I thought that like torch broadcasting rules would make it so that that y is repeated for each of these guys. Torch broadcasting rules. 2 tensors are broadcastable if the following rules hold. Each tensor has at least 1 dimension. When iterating over dimension sizes, starting at the trailing dimension, the dimension sizes either must be equal or one of them is 1 and the other one does not exist. Aha! So if this one is 1, if I say I want my y to be of size 2 by 1 instead of just 2, then maybe it'll broadcast. So reshape to 1, or n1 in this case. Look at that, baby! Boom! That's what I was looking for. So I have indexes that are incrementing by 1. starting at 738 and 655, which are the two random numbers that I came up with for where I want to sample from. And so I think now if I feed that into my image as indexes, I should get something reasonable. So we'll say that like self image indices, and we'll just put X in here for the other thing for now, just to see. Let's see it, baby. Fuck! We're close. 2, 19, and 2. Indexing tensors cannot be broadcast together. Can I just say, like, put 0 in here or something? I don't really give a shit. Yeah, we got farther. Okay, hold on. So let's just print image at these indices. Let's see what we get. Maybe that's right. Let's print the shape. That probably is more reasonable. Because I just want to know the size of the thing I got out, which is a 2 by 19 by 1620. Okay, yeah, 6. That's so close. Because now I just need the X dimension to do the same fucking thing. And then I'll have 2 images of sample height by sample width. Let's go, baby. Okay, certainly this needs to be a function. So we'll say def extract samples for indices, or for index, or def indices from start length. Yeah, there we go. So then we pass in start, which is going to be like the left-hand side or top side of our thing, and the length is going to be like either the width or the height. And then we can just do this bullshit that we did where we arrange from 0 to the length, and then we repeat those, I guess starts, plural. We have multiple items. N is how many items there should be, but I think that we can just do -1 here to let it fill that in. I don't think we need to pass that in. Okay. And then we return indices plus starts reshape -1, 1. Okay. So here now, if we do, instead of all this, we say print indices from start len, and the starts are y, and the length is self.sample height. I spelt it wrong in one of these places. Indices from start len. Indices. There we go. Dude, spelling so fucking hard. He doesn't like the repeat at -1. Interesting. Oh, because we need to specify how many times to repeat. But I guess that's just starts shape 0. The first length of starts. Let's see. Does that give... Oh, here we go. Yeah. Boom. Okay. Factory out function. Let's go, baby. What model are you using to convert images into ASCII? We're going to make one up. So at the start of the stream, we basically came to the conclusion that if you just did a single linear layer of input pixels, output character classifications, that's like probably the shittiest network we could do. And then we'll work our way up from the shittiest thing to something that works. That's kind of our mental model right now. But first we need to train anything at all. So, okay, so what do we get? Our indices, we got this correctly. That looks right. Okay, so we can say now we have x's is equal to indices from start and length. The starts are the x, and the length is the sample width. Yeah. And the y's are the same thing, but with height and y. And then we can just get the image by passing in the x's and the y's. And what does our data look like? Now, if we do that. Fuck! Indexing tensors cannot be broadcast together with shapes 212 and 219. So that's interesting to me because... Oh, do I need to do... Hold on. How does this work? So... First of all, I should do y's. If I do y's, x's, is that what I want? Maybe my linear layer is wrong. We're so far from like even touching the neural network. All we're trying to do right now is like define, all we're trying to do is like extract samples of like n by m size from an image to feed into the neural network. And I'm just, as always, struggling with torchisms. So fucking hard, man. Okay. So, yeah, so I'm working on my data loader, exactly. Data is the image y's. Like, what the fuck is this? Image y's 2, 19, 16, 20. So my x's need to be, for each of these lowest dimension, I want like, fuck. So I want like all of these guys, and a subslice of these guys. Which means I should be able to do like everything, and x is 1. Maybe? Yeah, okay, that's what I want. I want number of items, height, and width. Which means, so this is giving me the right thing, which means it's kind of interesting to think that like the shape of my y's and the shape of my x's actually have to be different from each other. So maybe like reusing this function actually surprisingly isn't what I want. I guess for x's, I can just do x to x plus self dot sample width. Because it's the lowest dimension, I guess that's simpler. And then I guess this probably has to be cast to torch int, probably. And does that actually still work? Only integer tensors of a single element can be converted into an index. Alright, so maybe it doesn't like that. Maybe it doesn't. What the fuck is x again? Dude, it's so hard. It's so hard. My poor little brain just can't handle it. Alright, I guess we'll do it this way for now. This seems reasonable to me. Logic overload, dude, yeah, we've been there. And I'll just like fix me. What the fuck am I doing with these indexes? But I have data that matches the shape that I want, so, you know, we can move on, and I'll probably come back to this off screen, because I think it's, like, probably not that exciting for people to just watch me, like, bumble through, shitty, like, just poorly doing torch stuff. I think that's probably not that interesting. Okay, so we'll do the same thing, but for the comparison object, which is, like, the upsampled image that is in, like, the same size as the rendered text. So here we can say, x's for comparison is x for comparison. And instead of the sample width, we want the glyph renderer, the character width. Yeah. Glyph renderer car width. And I misspelled width for like the 40th fucking time today, so that's pretty cool. Love that. And we do the same thing for y's, but with the row height. Okay. And then we say data for comparison is the same thing, but instead of image, we're looking for the comparison image, and from y's, we're looking for y's for comparison and x's for comparison. Woo! Okay, so we're close. Indices must be long, int, byte, or bool tensors. So I think these guys probably have to be cast to integers, probably when we multiplied them by the width and height. They got like upcast to floats. No? What the fuck is this? Print Y's for comparison and D-type. What the fuck is this thing? Float 32, but I cast him. Oh, maybe these guys have to be ints as well. Dude, I'll fucking say it. The, like, duck typing in Python, like, I can't get behind people who think that, like, it's easier to have, like, dynamic typing like this. It's so much fucking harder. Like, I'm sure that, like, there's, like, another side of this conversation, but I struggle so much with, like, stuff like this, like, int to float. How are you supposed to, like, how is, like, a new programmer who's, like, never worked with, like, a static type system supposed to, like, get what the fuck is going on here? It's just, like, the same thing, but fucking harder. But, you know, it is what it is. We gotta work with Python because we're doing AI, you know? Data for comparison shape. Okay, so the data for comparison is like some sort of upscaled version of the data. And so now we've got data for comparison. We've got data. And now we have to find an efficient way to compare all of our glyphs with all of these samples. But in ML, it's not just about the data type, but matching dimensions as well. Dude, the amount of times I have to spend out, like, writing down shapes and then rerunning my program to check the shapes. I'm pretty sure that, like, the workflow is supposed to be, I'm supposed to probably be in the debugger. And when I'm writing this code, just, like, writing the code in the debugger line by line and then copy pasting it back into the script. I'm pretty sure that that's, like, the efficient way to do this. That's the point. People don't need to understand those types of program. But, like, the problem is that, like, you can't hide the complexity, I think. I think that, like, you really do need the types. And so, like, by hiding it, you're just making it harder. That's, like, my argument here, I guess. The notebook serves that purpose, but yeah. Oh, that makes sense. I could, you know what? Now I could see... Last stream, I was like, I don't really get why people would use notebooks. But when you say that makes a fuck ton of sense. That, like, the notebook really would help here. Okay. So, I have glyphs. I have a glyph for each character. I want to put the glyph for each character in a thing of data for comparison size, and then for each one of those, broadcast it into however many samples I have. So I guess we can, we do this for loop. We iterate each character. That makes sense. We render the character. And then we put it into the tensor that matches the shape that we want. And then we need to, like, stack those tensors together, I think, so that we can do our, like, comparisons all at once. Right? Because this is, like, a nice torch operator. And then we can just take, like, a max out of those, probably. So I don't know how to, like, iterating here, I think, is probably unavoidable. We have to do, like, the Python iteration because we're running Python code to get the glyphs, which is fine. We're only gonna have to do this, like, once per sample. That's fine. Probably, actually, we should do this once ever on initialization. That would be faster. So I'll just say fix me loop once on init to create the glyph tensors. But for now we'll do it here just so that it's like I'm not changing too much at once. And so what are we gonna do? We're gonna iterate over these. We're gonna create a tensor for each glyph, and somehow, I guess we could, like, pre-make our tensor of zeros with n row height width. And then all we have to do is populate that index in the tensor for each glyph. And then we can have scores for each item. So let's just print item tensor shape and score here. And I think that this will give me scores for each tensor for each glyph compared with the sample. Fuck! Index 2 is out of bounds for dimension 0 with size 2. Yeah, because this is not n, this is len car lookup. Okay. That seems reasonable. So here, this score thing isn't gonna work. But I think that our item tensor shape is now of like number of characters, height, width. Perfect. So we have characters, height, width, and samples, height, width. And we have to now get something that's... So, fuck. This is... Okay. Item tensor is characters, height, width. We have the data for comparison, which is n height, width. And which means that if we were to get like all scores for all glyphs, all scores for each glyph for each sample is what we want. So that's going to be NCS. Number of items, number of characters, score. Which means that an intermediate thing that we're going to need is the difference score for each one. So we're going to need something that's like number of characters. Maybe, I don't know if there's a way to go straight from this to this. Because like the score is the subtraction of this width height by this width height. It feels like there's a way to go in one step. But I could be totally fucking wrong. Because clearly like it's not letting me do this subtraction, right? Which I thought would work. I thought broadcasting would let me do that. But the size of tensor 5 must match the size of tensor B or tensor 2. So it's saying that the channels in n have to match. So I guess I could just do the same little trick where I duplicate this for each. Or maybe I duplicate the data for comparison by the number of channels, or the number of characters, I mean. Because then the dimensions line up and broadcasting will work. I think that'll do it. So item tensor minus data for comparison repeat in dimension len car lookup. How did we do this repeat before? We specify 1 here. Okay, let's see what that gives me. I think that gives me the shape I want. Print this thing dot shape. Who fucking knows, man? I'm so lost. We're really just kind of hoping for the best. What doesn't he like here? Fuck this line. I don't want this right now. Okay, so we got 10, 48, 29, which is close. I guess we want to throw an n in there. 2, 10, 45, 29. That's not quite right. We want to repeat this twice for each. 5, 2, 48, 29. That's close. 2 is the number. Hold on. So the item tensor is one shape, and the glyphs are another shape. Oh no, fuck. This is glyphs. This is items. And we have... Oh, I think I just got this in the slightly wrong order. I want to repeat the glyphs twice, not the data for comparison. I think. Who fucking knows? Item tensor repeat twice. And then len car lookup 1 1. I guess it's 1 1 1 1 1 1 1 1 1 1 1 1. I sound like a fucking crazy person. So items, we have 2 things. No, I did want the 5 in here, I feel like. I did want the 5 on the items. So I need to repeat the items for how many car lookups I have. 1, 10, 48, 29. So I've made one. I think all I have to do is a reshape in here, maybe? For 2, n, -1, -1, -1. God damn it. Only one dimension can be inferred. Len of the car lookup height width. Height is not defined. Self sample height and self sample width. Dude, I have absolutely no fucking idea if this is right. No idea. Oh, nice. It's not even letting me. 2/5/1912 is not valid for whatever the fuck we had over here. 1/10/48/29. Oh, it's not the sample width and sample height. It's the character size. Oh god. Car height is this fucking glyph render shit where we get the rendered height, and the car width we get from casting the width of a character down to an int. Car height, car width. Okay, now here, instead of sample height and sample width, we say car height and car width. Jesus, please, please. 2/5/48/29. Please let me subtract those. I fucking beg you. I fucking beg you, let me, please. Okay, so we'll say this fucking shit show of a line is subtracted from the item tensor. And please give me some scores. Okay, that gave me something. Print score shape. Which should give me... This is 2/5, so 2 images, 5 characters, width, height. Okay, so now we can just sum this over dimensions, the lowest one and the second lowest one. So I guess I sum this over dimension 2? Maybe? Which gives me what shape? I wish, can I do like dims? Can I like specify 2 and 1 or something? Like, can I specify multiple dimensions there? And this is the score sum. I did it too much. Dimension. Maybe let's read the fucking document. Sum. Dim. Keep dim. Fuck. Torch sum. Let's do some reading. Keyword arguments. D-type. What about like the dimensions? Dimension or dimensions to reduce. If none, all dimensions are reduced. So I want to keep reduced as the ones that are being summed, I guess. So if I do dimension 0, I should see... why is there an extra bracket here? Okay, if I do dimension 0, I should see 5/48/29. My glyphs are 5/48/29. Oh, so I'm summing on the wrong... It's smallest dimension is the first one. Sorry, so 2/5/48. Yeah, nice. So I should be able to sum on dimensions 2 and 3 and get 2/5. So for each sample, for each glyph, I have score. Nice. Okay, so print scores. What are the fucking scores? Oops, I have to print the score summed like that. Fuck. Um, so here, let's just print the scores instead of printing the shapes. Bad random number rule. Okay, so for the first image, I have the best score on the most white thing. And on the second image, I have the best score for the most white thing. That's reasonable. Let's go. And then we just pick up the max. Yeah. So best or labels is the torch max of the score summed on dim equals 2, 3. And print labels. So now we should have, for each sample, we should have one index. Fuck. Is it max index? Fuck. Wait. Okay, so here I just want the max, but along the first dimension. So we say torch max, the sum on dim equals 1. Yeah, and that gives you the indices. Let's, yeah. Okay. So like this. So I get index 3, index 4, index 4, index 3. You know what? Who fucking knows if it's right? But, those are numbers. And all of the types and shapes have kind of been like coerced into what I want. So we now theoretically get n samples where we have m glyphs. We compare all of the glyphs to all of the samples and pick the best one for each one. Holy fuck. What a fucking disaster. I'm just gonna like throw like a fucking fix f and here was a toilet. This is worth it. Trust me, this is worth it. We'll say toilet fix me. Here we go. And we'll just gonna huck this guy in there. Did I not copy this? Copy. Paste. Yeah. Here we go. This is important. Fix me. And we'll just write, owie, this all hurts so much. Please make it readable. Please. Okay. All right. So there's manual tracking variables for loop iteration is no longer needed. And I guess I should leave these comments in here. These are important for later when I try to debug. And now we should be able to return data and labels. Easy. I had no problems. Okay. So we can say data labels is equal to sample get samples. We say print data dot shape and labels shape. Please, God, please. Okay. So we have data 2, labels 2, and let's try like throwing in a little like 50. What happens if we try to get 50 samples? Boom. Looking good. Looking fucking good. Okay. So I wouldn't be shocked if we could actually just train now. So we just need to fix our criterion to be a binary or BCE loss. Was that what we said? Was that what we were supposed to do? Binary cross entropy? It's been a minute. They used, no, cross entropy loss. That's it. Cross entropy loss. And so now we, instead of our inputs being random numbers that we generate, we can pull in sampler, get samples, and let's just start with like 10 for now. Fuck it, blaze it. Data labels. Oh, hey Daniel. Thank you, thank you. I will have a good stream. We're pretty deep into it, but it's going okay. Okay, so expected values, we don't need to calculate those anymore. We get them from this sampler. And our network is run on the data. And the loss is based off the labels. And let's just print the loss every time. Not do any of this like logging that we were doing before for eval loop. And let's see if this like trains. Fuck, we were so close. I felt so good. I had it. Oh. Because probably I need to convert the inputs into linear. Yeah, so like here we have like data. Our network is expecting the pixels to be like flattened out. So this should be like data reshape as the number of samples by the height times the width. Maybe. Who fucking knows? Who knows? Hey, thanks for the sub. Good to see ya. Okay, mat1 and mat2 must have the same D type. Oh, they're complaining about data types. Okay. What is our data? Okay, so let's get a little crazy in here. Let's do this reshape. Data is equal to this, and let's print out data shape just to double check, as well as data D type. That should give us a clue about how fucked up it is. So 10 samples by 228 pixels, which makes sense. It's uint8, so I guess we need to cast these to floats. Let's just ignore the fact that these are totally fucking unnormalized right now. But for now, we'll say these are floating points. Just keep them as they were. Which means that we have to actually do an assignment there to get that. Okay. Look at this. We were getting loss values, baby. We trained a little bit. Look at that. We got through like some amount of iterations. And the loss was changing. Who knows if it's good or bad, right? But it's doing something. Which is pretty fucking sick. Pretty fucking sick. Okay, so sometimes the sampler is doing something fucking stupid. And in true programmer fashion, we're gonna say if you catch an exception, just fuck off and continue, I guess. We'll just try it again. We'll just keep polling until we'll get the data that we want. No. I'll fix it later, I promise. Okay. So I guess now the question is if we train this for a little bit and we run the network after we trained it, it would be interesting to see if we start getting something that's like kind of sane. So let's maybe every some amount of iterations just run the network to generate a full image of the image that we're trying to see, and we'll see if it like progresses over time. And it probably won't. It'll probably look like absolute fucking trash, right? But you know, we'll come back. Also, let's try to get more samples. I don't. It seems like it's like iterating fast enough that we can do more at once. And let's like maybe check my like memory usage at the same time. So train. It looks like the memory usage isn't like out of hand, so we could actually go like much higher. Actually, maybe like 200. Yeah, it's actually also seeming totally fine. Except that I can't cancel this. I can't cancel. Okay. I would be interested to see, let's not print the loss every time. Let's start by printing the loss. If I percent 1,000 is equal to 0, print loss. Just because I want to know if it looks like it's like going down at all. Fuck. No, print, not all of these. Get me out of here. Still too many. I'm still printing something every iteration. Oh, here. Okay. I feel like there's an I'm sorry for your loss opportunity joke in there. Oh, certainly, right? There must be. Okay. So... Oh, I wonder if my sample size is too big. It's probably hitting whatever edge case we have. Just like non-fucking stop. Maybe it's not that bad. Or maybe all of our time is spent loading data. Oh no, okay, we're getting through some amount of training. We did get to loss. So let's also print the loss on iteration 1. So let's say if it's equal to 1, so that we get the first loss printed. So the first loss, 67. Then we train for 1,000 iterations. My CPU spins. He's hurting. He's busy. He's working. And we just wait for a second. That number's lower. I wonder if it's consistently lower. Let's just kind of give it a second. Print fuck, I love it. Yeah, you got to be careful with those. I am fortunate now where I'm not in a real work environment because you can't like even doing those as a joke at work is so fucking dangerous, right? Because like, yeah, it can just get like, you can just bad. It looks like the loss is actually going down a lot. So I actually wouldn't be shocked if we were to like print the results of this thing right now. If it looked kind of okay. Yeah, I wonder if there's an easy way to check that. I would like to hit Control-C a few more times. Please let me out, Python. Please. It's just the first few iterations. Yeah, but like, it's going from like absolute, it's going from random to less than random, right? So like, it might do something. It's a very simple problem. Oh my god, let me out. So maybe every 1,000 iterations, let's just do the thing that we were doing before in our other script with some nasty copy pastes. Or maybe we'll actually get crazy and we'll factor this out into a function. Probably what we should do. So we'll say def render text image, and we will take in, I don't know what we're taking in. What did we do here? Oh god. When we were in here, we iterated our whole image by sample width, sample height. And then we calculated the brightness and adjusted the character. So instead of doing like this sampling, like this, we still sample the same way, but we run the neural network. I'm curious how come it's not handling an interrupt between runs. My guess would be that because its torch is like threading and putting like, it's running like it's running like multiple cores. I have more than 4, but it's running 4 cores at once. I saw like a 400% on my CPU somewhere. And my guess would be that when you Control-C, it's trying to like cleanly close the like child processes so that you don't just like have zombie processes just like fucking spinning on your PC. So I'm betting that there's like some interrupt handling that's like trying to be like, children, please come home, dinner time, and then like waiting for them to get there. And that's just taking some time because like I'm crunching so much data. Just a guess though. What do I fucking know? Okay. So let's just fuck it. We're copy pasting, right? We're copy pasting. You can't stop me. This is my stream. And we will say render full image. We paste this guy in here, and we take in height, width and height. Sample width, sample height. And So all of these guys who say sample width and sample height in all capitals, we have to fix those. So we say sample height, or sorry, S, sample. Oh, what am I doing? I'm not going to do a search and replace. I'm just going to type GUIW and search for a sample and spam next and period. I like that better. Woo! Whee! Let's pull, we need to pull in some of the cursor tracking stuff that we had in that other script. So we initialized our cursors for X and Y at 0, 0. We need to pull in our image. Our image is going to be passed in, as well as the glyph renderer. Renderer. And as well as we're going to have to do this like output image thing. And then at the very end, we're going to have to save this to some file, and we're actually going to name the file based off of how many iterations we've done. So we'll say .format iter. And so we'll just pass in iteration here as one of the many things. And maybe that's good enough. Who fucking knows? We'll see. So we'll say render full image. The image is stored in our network. No, in our sampler. The renderer is renderer. The sample width is sample width. The sample height is sample height. And we also need to pass in our network. Because instead of doing this to get the character, we are going to run the network on our data. So we're going to say net sample reshape to the shape of there's one sample. Yes, one sample. And he's going to be sample width times sample height size. Holy fuck! How many times can I mistype width? Dude, I'm gonna lose my fucking mind. Okay, sample width times sample height. And we need to pull in the net here. And I guess we also need the iter, I. And we say that the output is this guy, and then we say output is not accessed. What the fuck? There we go. So the output is going to be like 1, the number of characters. So we're going to have to take the max to find the best one. So we're going to say output torch max output and we're going to reshape the output to be 1 dimension here, and we're going to take the index of which one we liked best. So we'll say best car is equal to this, and or we're going to call it car IDX. And I wonder if that'll just work. That'd be so sick if it just worked first try. Who would have thought? It never fucking works. Ever. It's because of the data type problem again, I think. So here, to torch float 32, baby. Fuck! Why do you use F linear instead of NN linear? I think I'm not using F linear. I'm using NN linear here. Are you asking like why would you, or because I think I had F rel used somewhere in here because there's like they're not learnable, but I don't think I've ever done an F linear. I don't think. Yes, why would you? I haven't looked. My understanding, hand wavy, is that these like NN parameters that get placed in here, they get like automatically registered with the network. And then when you run the optimizer, you can like pass in your module and say like, hey, just iterate all my parameters. I could imagine a world where you don't want to deal with all that magic and you just want your fucking code to do what it says it does, right? Like this is like, so there's so much magic going on in Torch. I shouldn't say magic. I hate that word. But there's so much like stuff hidden complexity. And I could see a world where you would want to not use that. I would also assume that all of the parameters are like implemented using the functional versions of it. So hand wavy, that's my understanding. But what do I know? I always thought it was just weight init backpropagation. Well, I mean, like the fact here that like the optimizer is only going to optimize the weights that it finds by iterating your module, right? So like when you construct this like nn.linear, we've actually we saw this last stream. I'll just comment out this like super init. And he says, yo, you cannot assign a module before a module init call. And all I'm doing is I'm like assigning a variable here. So like you could like, and the fact that I can like call network named parameters and it like finds all of my weights and biases in there, it just means that there's like something happening in there that I don't understand, right? Like this nn linear must be registering, doing some form of registration with nn module, right? Like if we go in here, we can probably find that like parameters probably do some like wonky shit. But that's for the backpropagation tree. Yes. And I'm just saying that like I could see a world where you would want to track all of that stuff manually instead of doing it through like Torch's underlying mechanisms. When I was like Googling like what the F versions were, they were like, yeah, you just have to pass in weights manually. And I'm like, oh yeah, I can see why you would want that, I guess, in some worlds. Okay, what was I trying to do? I was trying to run the network, see if it works. And it doesn't like mat1 and mat2 must have the same D type. So somewhere I fucked up. So here I have output, reshape, 2, torch, float 32. Oh, oops. The 2 float 32 needs to come here. Needs to come over here. 2, torch, float 32 as an input to the network. I don't give a fuck about this. Index 1 is out of bounds for dimension 0 with size 0. Okay, so we're close. Print output? Like, what the fuck? What did I get out? Print output is an output with 5 guys, which makes sense. So why is when I try to get the max of my output, why is he... oh, is it... Where did I call max before? Torch max over some dimension. I remember this being like having indices. Am I high? Am I high? Let's just print torch max output and just double check what its output is. Oh, his output is just the number? How do I get him to give me the index? Which is what he was doing last time I did this. And why is it different this time? Fuck me, man. Input, dim, whether or not that has dim retained or not. Out, tuple, optional. The result of 2 output tensors, max indices. Yeah, so why the fuck would he not be giving me indices here? Oh, because here he's not getting any indices. Oh, because I need to pass the dimension to get the indices? Okay, whatever. Okay, sure, whatever. I'll max them out along the first the second dimension. And then I get the indices as number 3. Yeah, that looks right. So car index is this, and just like another one of these, like, fix me, what the fuck am I typing? I probably shouldn't even bother commenting individual ones of these because it's probably just fucked everywhere. But it's fine. So now we should have a 1.pung. Oh, which is already, interestingly, somewhat looking like the image, but it's now interesting to see if 1001 is any better. And it actually is just getting way fucking worse. Oh, that's so funny. Holy shit. It's just like random initial weights give me like a better fucking answer. That's so funny. Oh man. Yeah, that's pretty sick. Okay. Do I want to do more now? It is interesting. I mean, like, it is still keeping some form of shape. It might be... Maybe we give it a little bit of time. You know? Let him think a little. Let him cook. Okay. I mean, he's clearly learned... Well, I guess there's, like, lots of chance for bugs. Is it getting better? I don't fucking think so. It got worse, and then... I mean, clearly it's doing... Let's say, at the very least, it's keeping shape at least a little bit, right? Like, it is learning... There is, like, some form of, like, locality here, right? Like, we can see here, just so that we can, like, look at the sample that we're actually working with. This guy. Like, at the very, very least, the thing we've trained has, like, identified that there are, like, dark pixels here that it cares about. That one's just shit. But okay, like, there's a lot of reasons that this could be happening, right? It could be, like, learning rate, it could be something, but, like, the fact that it's, like, at least trying to track the shape of the hill at all indicates that we're on the right path, right? Like, the fact that we're training something that has learned something about the inputs, and it's just not learning them well enough. Which is pretty sick. Pretty sick. And keep in mind that our network is, like, fucking stupid. It's, like, the stupidest network of all time. There's, like, 0 hidden layers. And we haven't tried to, like, tune learning rate at all or anything. It's definitely not good. But I think I'm happy with that for now, just because, like, just getting the code to run is, like, I think that's, like, a non-trivial task, especially for me right now with, like, my, like, current understanding of everything. So I think I'm gonna call it there for today, because we're over 2 hours. We're at 2:10. And yeah, I think I'm pretty happy with that progress. So I think probably what'll happen is I might do some, like, tweaking of weights, and, like, I might try overnight doing some, like, learning rate adjustments and stuff, just, like, some, like, minor things when I come back after, like, eating or whatever. And we'll be back at it tomorrow with trying to, like, hopefully by tomorrow I'll have an idea for what I want to do next, which could be, like, visualization of training curves and, like, visualization of, like, individual samples, and maybe trying to, like, tune the weights and the biases and the network shape and whatever. Like, I'm sure that I'll have some idea for where to go tomorrow. So we'll be back at around, like, 1 or 2 Pacific time. If you missed stream and you want to catch up, there's a YouTube link in the Twitch description. So if you go subscribe there, you won't miss the next iteration, even if you're not available live. And if you're watching on YouTube and you want to come tell me why I'm a fucking idiot, help me write better code, there is a Twitch link in the YouTube description, which you can come and chat, say hi, whatever. Yeah. Thanks for watching, you guys. It's a fun stream, and I'll catch you on the next one. Bye!